Step 6, oxidation and phosphorylation. In this step, the two molecules of glyceraldehyde 3-phosphate will suffer from oxidation and phosphorylation in the presence of glyceraldehyde 3-phosphate dehydrogenase enzyme and react with the two groups of phosphates will come from the inorganic source instead of ATP source as the previous steps and forming new compounds which is 1,3-bisphosphoglycerate. Here we can note the 1-phosphate group here in linked in site 1 and other phosphate group linked with the 3 sites of the glycerate group. This process also includes convert of 2 NAD plus into 2 NAD H plus 2 protons. Step 7, which includes first ATP forming reaction as follows. In this step, two molecules of 1,3-bisphosphoglycerate compound will convert into two molecules of 3-phosphoglycerate by releasing of phosphate group from the active sites of carboxylate and released this group to form the carboxylate compound as 3-phosphoglycerate. That will happen and present the phosphoglycerate kinase as enzymes catalyst, and this reaction will involve also convert of 2 ADP into ATP, which is released as energy. Steps 8 to 10. In step 8, we can note that the two molecules of 3-phosphoglycerate will convert into two molecules of 2-phosphoglycerate. This rearrangement reaction will include the move of phosphate group from side 3 carbon into second carbon in this compound and create a new compound 2-phosphoglycerate. This reaction will happen in the presence of phosphoglycerate mutase as catalyst, and this step will follow by another step in the presence of enolase. This 2-phosphoglycerate compound will convert it into the phosphoenol pyruvate compound by releasing the molecule of H2O and create the carbon-carbon double bond. And the final step here in the presence of pyruvate kinase, the two molecules of phosphoenol pyruvate will convert it into two molecules of pyruvate as the final product of glycolysis process. This pathway will include also converted of 2 ADP into 2 ATP as released energy. Now we can summarize the glycolysis process by the following points. Firstly, the 6-carbon glucose is cleaved into 3-carbon pyruvate, as well as there are 3 types of reaction involving in this process, which is degradation of glucose into pyruvate, phosphorylation of ADP into ATP, as well as transfer of hydride ion to NAD plus to form the NADH. Also, the main phases of this process can be divided in 2 main phases, which is from step 1 to step 5, named preparatory phase, and from step 6 to step 10, can named as payoff phase. Overall of this phase, the net yield of energy will be 2 molecules of ATP per 1 molecule of glucose, as followed by the preparatory phase, the 2 AP are invested. However, by the payoff phase, the 4 ATP are gained.